Ladies and gentlemen, welcome back. Those of you that were here a little bit earlier on this morning, you'll know exactly what this is all about and kind of what to expect as well. If you weren't here, let me just quickly explain what this is all about. And if you're walking past at the back, not quite sure what this is, come on in, take a seat, get comfy, because you are about to hear or see, experience, and get to know 10 big ideas. 10 big ideas within the composite industry, and these are all within the category of process, manufacturing, and equipment. This is the Startup Booster Competition, the JEC Startup Booster Competition. So in terms of composites, in terms of startups, this is the main global competition. It's where you could be, it's where you should be, and hopefully if you're here as one of the finalists, you actually might make it through winning one of these prizes. Remember, what are they winning? What do they want to walk away with? Well, what do they want? I'm sure it may be different from what they get. However, what they do get is 25,000 euros package, a 25,000 euros JEC World package. And part of that package is a cash prize. Part of that package is fantastic media coverage within the industry. And if you know, those of you that have been here before, or maybe one of the finalists before, you know that it's very valuable indeed having that here at JEC World as well. And also next year having a booth here as well. So very valuable winnings indeed. So we have got 10 big ideas standing on this stage. Very simply, what will happen is they will stand here, they will share their message for 5 minutes, up to 5 minutes. So they can do it less if they want to. Some of the strongest pitches are actually a lot less than what they should be, up to 5 minutes. And then it gets a little bit more tricky, because our jury members here in front of me right now, they will start to ask a few questions to dig a little bit deeper underneath the bonnet, really to find out how these startups tick, how they really understand some of the questions and answer those questions to help them decide who walks away a winner at the end of the day. We won't find out who the winners are of this morning's session or this session until tomorrow. So remember, whatever you're doing tomorrow, walking around, having conversations, having meetings, make sure 3 o'clock tomorrow afternoon here on this stage, this is where we'll hear who the winner is of the category this morning, the winner of this category, and also there's a third winner, a third special winner, not more special than the others. However, this winner is basically essentially for the most sustainable solution heard during the pitches as well. So we find 3 finalists tomorrow at 3 o'clock. So naturally, this competition, which has been going since 2017, every year we find, we nurture, and we showcase these big ideas on this stage. Would not be possible without the support, would not be possible without our partners really supporting this concept and driving it forward as well. So a big thanks naturally to Airbus, Mercedes-Benz, Owens Conning as our main innovation partners, and also Mitsubishi Chemical Group as our innovation partner as well. Now, our jury members, who are they? Where do they come from? What are they? More about them? I can't tell you more about them at all. However, on the screen, we can see exactly who they are here. So these are our 5 jury members. Naturally, you can see they are from companies, they are from organizations that know what they're talking about, that hear big ideas all the time. So they clearly know what they're looking for and know how to ask the right questions as well. So we thank you again for sharing your energy, sharing your knowledge, but most of all your time as well. Shall we start off with the first startup? Absolutely. And remember, startups, they're coming from all over the world as well. And as you hear them, you're curious. You'd like to know more. You might be skeptical. You might disagree completely with everything they're saying, but you want to have a conversation with them afterwards. Remember, you can do it straight after here or at the Startup Village startup booster village, which is in Hall 6, this hall here. As you come down the escalators on the other side of the hall, a large area there, and that's where every single one of the startups will be ready and waiting for the same thing you're here to do, which is have conversations. Right. Let's start with our first startup. So we go to Italy, or Italy comes to us, rather. Italy comes to us right now, and this is all about an idea which is unlocking the full potential of advanced composite materials with topological optimization and innovative manufacturing solutions. It's lots of big words. It sounds exciting. Let's see if the pitch is as exciting as those big words. Let's find out. Ladies and gentlemen, please welcome to the stage CTO and co-founder of ADDYX, Mr. Matteo Di Fulvio.
So good afternoon to everyone, and I guess I can start. Okay, so our aim in ADDYX is to unlock the full potential of composites. So today I'm here to introduce you to carbon exoskeleton, our novel topology optimization technique to empower our customers for the design and production of high-performance composite structure. Sorry. We faced a challenge in ADDYX, how to introduce topology optimization in the composite field. So the traditional techniques, like reinforcement plies and sandwich structures, have a very low efficiency. So we developed the carbon exoskeleton, which is a novel paradigm for the topology optimization in composite. Consisted in a long fiber topology optimized ribs on the internal side of the components. The ribs can vary in width, density, and thickness. So you can locally reinforce and enhance the mechanical properties of the component, avoiding the usage of honeycomb and other cores. This makes the final components lighter, stronger, and more affordable. How to manufacture the carbon exoskeleton? We use our VSM 170, which is a water-soluble expanding mandrel. So you can follow the path on the mandrel, filling it with the long carbon fiber. Then you can wrap the mandrel with the external skin, and the one-shot consolidation process in the external mold in autoclave or autoclave will bond perfectly the ribs to the external skin. The water-soluble expanding mandrel is a novel technology patented by ADDYX to produce hollow, complex-shaped composite component with virtually no limitation in the complexity. It is also a very cost-effective technique. So making one-shot net-shaped component and avoiding bonding and trimming, you can cut the final cost of the component up to 50%. Also, it is a very versatile technology. You can use it in autoclave or autoclave. In ADDYX, we follow the principle of circular economy. So there's an ongoing project with a research center to re-extract the polymer from the dissolution water, extrude it, and making new mandrel with the recycled polymers. We have a production plant with more than 70,000 hours per year of production facility. And we are already suppliers of Formula One teams, other motorsport companies, automotive companies, and aerospace companies. With the help of our industrial partners, there are also ongoing projects to laminate the carbon exoskeleton on our mandrels. So thank you for your attention, and please come to have a chat with us at our booth in the Startup Village. We have some real carbon exoskeleton components to show you. So I guess that's it with my presentation. Maybe I was faster.
Absolutely. Ladies and gentlemen, hands together for ADDYX. Fantastic. Right, my colleague is going to give you, he'll give you a microphone right now. Come towards me. Stand in the center there. And this is where we listen to our jury members and hear what they feel about what they've heard. Okay. Let's hear from them right now.
Thank you, Matteo. So is that coming through? Very interesting presentation, and great to see circularity as a key theme. A lot of the current water-soluble mandrels are quite difficult to remove. How does your product differ?
All right. So our mandrels are made out of our patented product. So our patented polymer, and the dissolution. We care about dissolution time. So I can tell you that the dissolution time can vary with temperature of the water, obviously. You can dissolve our polymer in just tap water without any solvent. And if you have some time, you can dissolve it in cold water in 4 to 6 hours. If you don't have time, you can use hot water and dissolve completely the mandrels in minutes. So we tested the dissolution time at 95 degrees C of water temperature, so near the boiling temperature of water. And the dissolution time was about 5 minutes, so very fast.
Thank you very much.
Great, President. Great.
Should be okay. Try the other one. There we are.
How about this? Ooh, how about this one? That's fine. Interested to hear about the team. Who's on your team?
I'm sorry?
Who's on your team?
Okay. So our team, we are actually an additive manufacturing center, because our mandrels are produced in additive manufacturing, but almost all our team come from the composite industry. So we are 6 people right now. I'm the CTO, and I'm coming from the composites. I have experience in pre-preg makers and composite components makers, and all the rest of the team, like R&D manager and sales manager, comes from the composite industry. So we know how to face the composite challenges, and we are ready to solve it.
One more question, yes?
What is the current stage you are in your process? Meaning, you are where in the development of your company, and what are the next steps?
I'm sorry, I didn't hear the...
At what step of the development of your company you are?
Okay, so we are now producing water-soluble mandrels. So we are suppliers of a number of Formula 1 teams, and we are also suppliers of aerospace companies and automotive companies. Regarding the carbon exoskeleton, we just presented it to JEC show this year. So there's a couple of motorsports companies that are testing the exoskeleton now. So we are testing all the mechanical properties and the difference between the traditional approach and the carbon exoskeleton in terms of mechanical properties.
And there we have it. There we have it. The jury members seem to have everything they need. You've shared everything you need, and our audience are happy as well. Ladies and gentlemen, hands together for ADDYX. Well done. Thank you so much.
Thank you very much.
So there we have it. There's our first startup there. That's the drill. That's how it unfolds. Startup, idea, jury members, jury, like they are right now, focused, putting down their ideas. I have no idea what they're thinking. Again, still poker-faced. They may just be poker-faced, just generally, I don't know. But right now, they're popping down how they feel about everything. Again, as you listen, you're curious as well. You'd like to know more. Also, Startup Village, pop over there, chat to any or all of the startups that share their big idea here on the stage. And I'm sure you'll have your favorites as well, favorite of this session that you'll put through if you were sitting in one of these chairs. Right, let's move on. So we started in Italy. Well, Italy came to us. Korea next. Korea coming to us right now for this session. This is all about an innovative recycling company that really uses 100% eco-friendly technology to recover high-quality recycled carbon fibers from waste carbon fiber reinforced plastics. Intriguing, as much as it's intriguing for you, for me as well, hopefully for our jury members. Let's hear exactly what this is all about. Ladies and gentlemen, please put your hands together for the Director of Global Business Development at CATACK-H, Hendrik NEUHAUS.
Hello, I'm going to talk about carbon composites recycling via Thermolysis today. Our company CATACK-H is located in South Korea and was founded by our CEO Jin-Ho Jong in 2017. The technology is derived from the KIST, which is the Korean Institute of Science and Technology. Jin-Ho Jong, our CEO, was able to form a team around him and develop further this technology into a 2.0 version that we are using currently. As we all know, carbon fiber has been around for decades. It's appreciated for its outstanding characteristics, and it's now finding its way into more and more emerging markets like high-pressure vessels and wind blades. And thus it becomes a key component in the transition to a sustainable and circular economy. We have identified two problems with carbon fiber. First, or to realize the dreams of these emerging markets, one is the supply of the continuous carbon fiber today is already in a shortage. The second problem is a huge waste generation, not only from post-industrial, but also from post-consumer waste, where you're losing a high-value resource. Incineration and landfills are not an option really anymore. It's prevented by governmental restrictions, and companies are just looking for a more environmentally friendly solution. That's where CATACK-H comes in with its new technology, where we have formulated a solvent process based on optimal conditions. What I mean is we operate under very low temperatures, so below the boiling point of water, under atmospheric pressure, and we have a very short processing time. The very unique aspect about our process is that we have zero waste out of our process. So we not only recover the fibers, and we also recover the resins. We can reuse the wastewater that we have, and also the chemicals that we're using. So we basically have identified four major advantages about our technology. One is, as I just said, it's zero waste, so it's eco-friendly. We recover the fibers, the resins, and as you can see here from the chemicals, we can make vinyl ester and make new products from there. A second big advantage is very low energy use, only 30 megajoule per recovered fiber, only 2.5 kilogram of CO2 load on the kilogram of recovered fiber. Third advantage is we have a very high yield. Depending on the application or the scrap material that we are processing, we get up to 100% of fiber recovery. And the quality, as you can see here in the picture, is also, we have a very pristine fiber, no residues, no impurities. It's very easy to process for compounding or textile fabrications. So just one example, or like two examples, where we have actually two different types, if you want, of carbon fibers. One is a discontinuous form, so in short or long fiber. Here's an example from the aerospace scrap. And then the latest breakthrough that we had, and this is where we solve the first problem of the supply issue. We can now also recycle and recover continuous fibers from pressure vessels and unwind them and make new tanks out of them. In a proof of concept project, we have also shown that we can do wind turbine blades. And then products that we're making currently out of our fibers are milled and chopped fibers for compounding, for example, but we also have our own felt production lines, and then making our own pressure vessels. So the next steps for our company will definitely be to establish and gain a stronger foothold in the Asia-Pacific area, get into mass production with RCF composites, and we are still looking for partners to establish recycling plants over here in Europe, in the US, and Australia. So I hope to get into a discussion with potential partners, investors, and I hope you can find us at our main booth in Hall 5, M82, or you can always come see me after the show here or send me an email. Thank you so much.
Ladies and gentlemen, CATACK-H, well done. Fabulous. You have a microphone in your hand. Come and join me here in the center. And let's hear again from our jury members how they felt about what they've just heard from you.
Is this working yet? It is now. Yeah, great to see the circular approach, and not only for the fibers but for the resin. My question is, what's your route to cost and the economic efficiency of this, and then scale up?
Cost is, of course, a question that we always get, and it's always a little difficult to answer because we have a variety of products that we are offering. In terms of like the plain chopped fibers, we're currently working on a 3rd generation equipment that we hope to have fully operational by the end of this year, and we are targeting $5 per kilogram for just the plain fiber that comes out of our process.
You said you were going to strengthen the foothold in Asia. Are you focusing Asia only, or are you also present in Europe?
So, I mean, CATACK-H is based in Korea, so that's our main focus right now. So we want to just be present there. We have good partnerships with Australia even. And definitely want to get a better scrap collection structure from the Asian countries. But as I mentioned in my presentation, we're looking into Europe as one of the first markets that we want to expand to. Already we have gotten into a lot of partnerships with potential joint venture partners or investors here. So there's a lot of interest from the European market for sure.
Obviously, one step at a time.
Thank you.
I suppose the last question, so carbon fiber is one thing, but glass fiber is much more important. Does it work with glass fiber?
Thank you for that question. We get that question a lot, of course. As I showed in my presentation, we had a proof of concept for glass fiber recycling with the wind blade. As a startup, it's difficult to focus on different materials. So we currently focus on carbon fiber, also with the idea to have a higher margin, higher value product. But I'm sure there's a need in the industry, of course. So I encourage every other company that does the glass fiber recycling, of course. Yeah.
And there we have it, ladies and gentlemen, hands together for CATACK-H. Thank you so much.
Thank you.
There we have it. So another one of our big ideas here on stage. Again, our jury members, they are focused. They are now evaluating how they felt about what they've just heard. Will it be a winner? Will this walk away? Will this startup walk away a winner? We don't know. We'll find that out tomorrow, 3 o'clock on this stage right here. But for the time being right now, let's move on now to our next big idea, next startup of this category. Now, this is where Switzerland, I say we go to Switzerland. Switzerland really comes to us here in Paris, and this is all about separating resin from the fibers. Old chestnut, separating resin from fibers, but developing this in a highly energy efficient and sustainable process. So let's hear what that is all about. Ladies and gentlemen, hands together for our next startup, which is simply, well, the person who's going to do that is the CEO of Composite Recycling, Mr. Guillaume PERBEN.
Thank you very much. Good evening. I'm the CEO and co-founder of Composite Recycling. I'm also a skipper. And a lot of people in my team, we love sailing, and we love the purity of the wind that enables us to push our boats on the ocean. What got us thinking about composite recycling, coming back on the last question that was asked on glass fibers, is that we know that our boats are efficient, durable, easy to maintain, thanks to composite materials. We also know that at the end of their useful life, our boats are very likely to end up like this. And the UK Practical Boat Owner magazine has calculated that there's about 100,000 of these boats that reach the end of their useful life every year, and they end up mostly like this. The reason for this is known to everybody, is because the industry cannot efficiently or economically separate the fibers from the resin. And the only solutions today for boats, but also for wind turbines, for all these composite materials, is to landfill them or burn them. You can call it combustible or you can call it whatever, but it's burnt. And that really got us thinking. So we looked at this, and what we came up with is, instead of trying to use universal machines that could try to separate the resin from the fibers on all sorts of composites, we decided to focus on a machine that was doing glass fibers using a thermal process. So unlike the previous presentation, we focus on glass and we focus on composites. We don't know how to do tires or plastic chairs or anything, which means you put the pieces of composites or boat or anything in a static chamber without shredding, and you remove the oxygen, you heat, which vaporizes the resin. The condensable part of the resins become oil, which is a product that you can sell, and the non-condensable part becomes gas that powers the unit, so it's autonomous in energy. We don't use outside source of energy. The resulting fibers and oil are recovered, and we clean them with a post-treatment. This is, in Switzerland, we work with the École Polytechnique Fédérale de Lausanne, and we've developed a post-treatment because you can see on the example, we have not moved the fibers, we have not shredded them. So the roving here is black because it has microns of soot on it. It's a little carbon residue. This we clean with our post-treatment. And the fibers that we recover, you can see on the electronic microscope that they're coming out very clean. We can then post-treat them and combine them with new resin to make new composite materials. We focus on matte because that's what those fibers are best suited for. But we close the loop, meaning that we take a composite, we separate the resin from the fiber, we clean the fibers in an energy autonomous system, and we recombine them with resin to make new composites. We started with boats because you need to start somewhere, and we have good connections. We work in partnership with the Groupe Beneteau on this. In France, there's 200,000 boats today to be treated. In Europe, it's 2 million. Canada has counted 6 million hulls to be treated. And of course, there's the 10 millions in the US, and then there is the wind turbines. What we try to do, and that's why we work with partners of the whole value chain. So we have an agreement in France with the boat deconstruction branch to collect the boats. You can see it's a container because we don't want to transport bulky waste. We want to come on site. So I'll come to it later, but the unit is mobile. The revenue streams are collecting what otherwise would be spent as landfilling cost and then sell the recovered glass fibers and oil. The fleet of containers is deployed and comes treat the waste on site. The team, we made sure that we have scientists, engineers, but also people from the industry that we work with all the time. And that makes sure the solution is, of course, it works scientifically, technologically, but it's realistic, corresponds to what the market wants. The IP is on the fact it's a mobile container. We have just completed our fundraising round. We're building the container. It's delivered at the end of the year. We're also selling tests that enables us to, we have so many demands from companies saying, can you show that our product is recyclable? We do that. We can demonstrate that your product will be recyclable. We have been very fortunate to be supported by very prestigious organizations, and I'm waiting for your questions. Thank you for your attention.
Ladies and gentlemen, composite recycling, well done. Come and join me here. Give it a round of applause, please. Come and join me here. Fantastic. Okay. Confident pitch. Let's hear how confident it was in the minds of the jury members.
Hopefully you can hear me now. Excellent. It's great to hear someone talk about glass. Fantastic.
Thank you so much.
I think it was a very great pitch. I mean, for me, the question I would have is, what do you think is going to be the next big challenge for your organization as you scale?
We don't know how to industrialize this. This requires a lot of experience. And because we don't know that, we limit the scope of what we do to just supplying the raw material, which is the reclaimed fibers. That's why we have made the first tests and the first partnership with Shomara, and they have produced successfully the first rolls of mat. So it's still in the process of testing, but the challenge is we need to understand our limits. We can't say we're going to produce everything all the way, so we just stop there and we let the experts do the next phase.
And I think the other question I would have is, the oil for me is always a question, right?
Sorry?
The oil is always a question. How do you drive the use of the oil or the sale of the oil?
There is a very fierce competition to get pyrolysis oil from companies like BASF, INEOS, Total. BASF has created a whole new department a couple of years ago called ChemCycling. There's a company in Germany called PERBEN. They do the same thing as we do with tires. BASF has put 16 million euros to get 10% of this company and the monopoly on pyrolysis oil. With pyrolysis oil, you could use it to make fuel, but you don't want that. This is not good. What INEOS, BASF, and Total, for instance, what they do is plastic. And that plastic has a raw material cost which is stable, because it's all boats, right? And it's decarbonated. So there's a real competition for them. They have our oil, they're testing it. The discussion is more about how much they pay for what quality.
Cool, thank you.
Intriguing for everybody. Ladies and gentlemen, hands together for Composites Recycling. Thank you so much.
Thank you very much.
There we have it. It gets, as you can hear, as we go through this category, as we did earlier on this morning, the ideas get stronger, they get more intriguing, and naturally the curiosity level rises as well. If it reaches to a point where you feel you're curious, you'd like a conversation, you'd like a chat, you'd like a coffee perhaps, and get to know these ideas a little bit better as well. Again, Startup Village, Startup Booster Village, hall number 6, which is this one at the front by the main escalators. There's every single startup's there, ready and waiting. They're here today, they're there tomorrow. Have a chat, have a coffee, and get to know a little bit more, as we're doing right now, all of these startups and big ideas. Right, let's move on. Now we go over to, again, it's a UK-based startup. They are coming here to us, to Paris, and this is all about producing next-generation advanced carbon fiber composites. Let's find out more right now. Ladies and gentlemen, please, hands together for Chief Technology Officer of Lineat Composites, Lourens BLOK.
Good afternoon, everyone. My name is Lourens BLOK. I'm CTO and co-founder of Lineat Composites. Lineat is a clean tech startup based in Bristol in the UK, and we've radically reinvented the way we use carbon fiber to make it an easy multi-use material of the future. And with that, we are forming the future of high-performance, sustainable composites. The need for lightweight and reusable materials is higher than ever. Transport accounts for almost 1/3 of global CO2 emissions, so we need to make lighter materials. Carbon fiber is such a material. In the US fleet alone, we can save almost 50 million tons of CO2 by lightweighting, and we know the solution is lightweight carbon fiber. So why aren't we making more out of this material? The problem is 3 main things with carbon fiber. First of all, it's an expensive material. It's manufactured at high temperatures, so the material is expensive, and once you have it, manufacturing is complex, adding cost. Even if it was cheap, it's a slow process to make a part out of it. This is often relying on slow layer procedures, used single layer by layer. And third of all, it's highly wasteful. During production alone, we throw about 30% of this valuable material away. That's about 5 tons for an Airbus A350, worth over £500,000. And at end of life, we don't have any solution available. So this means that by 2030, we accumulate almost 500 million kilos of carbon fiber. adding to the impact, the negative impact of this material. And this is where we focused our solution on. We can reclaim high-value chopped carbon fiber, and we align these into highly aligned tapes for easy reuse. Due to the high level of alignment, we obtain a strong material that can retain almost 90% of its performance compared to an equivalent continuous fiber material. And not only that, we add a unique shapeable aspect. Due to the highly aligned architecture, this material can stretch and form easily around complex shapes, solving this manufacturing challenge. And lastly, it's sustainable, allowing use and multiple reuse of carbon fiber to reduce cost and carbon footprint. And this isn't something we just talk about. Last year, we've started the Carbon Fiber Circular Alliance with the World Sailing Trust and taken broken tennis rackets, reclaimed the fibers, and made a new tennis racket. And we've done the same with the Paris Olympics IQ foil mast that you can see at the entrance of the JEC. So this is how we're turning carbon fiber into multi-use material of the future. We're the first fiber alignment technology on the market, working with the carbon fiber supply chain. So there's numerous fiber reclaimers. In the picture here, you can see our pilot line in Bristol. It's essentially a high-tech paper-making process where we disperse these fibers and then bring them together in an aligned tape. And this tape can be used for part manufacture in different routes. We already have tractions in the sports market from that project we did last year, and starting demonstrators in automotive and early R&D in aerospace market. We have a scalable solution. So in the last 2 years with our pre-seed funding, we've gone from startup prototype to pilot line, and we've shown that this can be done in the sports industry, and we've got a clear technology and product roadmap ahead to turn this to an industrial scale, where we're building 2 industrial plants in the next 4 years, and we're currently raising seed funding for this to turn break-even by 2026. So looking at the market, this is a huge opportunity to enable economic circularity for carbon fiber. We see about 30% of this market to be cost and sustainable driven, and we're aiming to capture 10% of this market. But we're not stopping there. We want to turn the 10% carbon fiber recycling rate to over 50%, and we've got a business model to license this technology and offer bespoke carbon fiber waste solutions. We've got the team to deliver this with a strong academic roots from our origins on the University of Bristol to now a diverse team with 13 people spanning over 11 nationalities, covering commercial, composites, but also the very important machine building exercise. So in short, Lineat is making more out of carbon fiber. We've got a greener, cleaner, and the first formable material, composite material available. This closes the loop for carbon fiber and enable economic circularity at a lower cost and carbon footprint. So if you're interested in working with this material, we're in the startup area in Hall 6 at H4. So come and see me, and happy to answer any questions.
Ladies and gentlemen, just in time, Lineat Composites. Fantastic. Right on the gong. Right on it. Right, come just over here slightly. Okay, let's hear from our jury members what they felt about what they just heard.
Thank you very much, Lourens. Really great to see this reuse of recycled material. What's your route to exploit and find those future end uses?
So I think we've got a really interesting product here. What we're seeing in Lineat is that sustainability is really opening the doors. And this is really useful for getting tractions in sports, where the added value is actually that it is reclaimed. Other industries, cost is key. We need to get the cost down for carbon fiber. And that's where we're focusing on now, really with the formability of this material, which is the origins of the early research on how this can be an easy to manufacture composite material. So we get an initial traction selling this material from a sustainable aspect, and then we're going to cost model what the cost savings are when you would move from, for instance, a unidirectional blank preform sheet to an aligned preform sheet, and what cost savings and time savings that can give, and ultimately turn this really into a high volume, low cost material that can compete with lightweight metals.
Thank you.
Great presentation. Interested to know what the property loss is if you compare versus a virgin material. How much are you giving up?
So the property loss versus perfect continuous UD depends mainly on two things. One is the reclamation step. So that's where the reclaimers, you've got different technologies. We've seen presentations earlier that can be as little as 5% below continuous. That can vary a little bit when you go to industrial waste. The second property loss is our alignment, and that really depends on how well we align our fibers. Theoretically, we should be able to obtain about 95% of the continuous fiber properties with our level alignment. We've hit 86 on an equivalent percentage, so we're a little bit lower, and we're working on cost modeling this as a, okay, if we're 80% lower, our price will be 80% lower as well.
Cool. So work to do then.
Right, ladies and gentlemen, there we are. There we are. Please put your hands together for Lineat Composites. Thank you so much. Well done. There we are already for halfway through this category. We're on to our fifth big idea here on stage right now. And again, if you just joined us listening to process manufacturing and equipment category, we will find out who the winner is of this category tomorrow at 3 o'clock on the stage. Our jury members later on today, they will come together and they will decide who the lucky winner is of, lucky deserved winner is of this category, the category this morning. And remember, there's also one other category, one other winner, which is basically the best sustainable solution out of the whole 20 big ideas, 20 startups, one winner walking away as the best sustainable solution. And we'll find out all about that tomorrow at 3 o'clock. In the meantime, let's move on now to our next startup right now. So we were in Switzerland. We weren't in Switzerland, but we're going to Switzerland, or better still, Switzerland comes to us right now. So our next idea, all about agile and modular circular composites solutions. Let's hear more about that right now. Please welcome to the stage chemical process engineer from Microwave Solutions, Brendon TROLLIP.
Many thanks, Peter. Microwave Solutions, the answer to the complex issue of composite circularity. Composites with their high performance capabilities have become essential in various industries, but due to their complex composition, achieving circularity has become a major issue. However, we at Microwave Solutions have developed a fully circular composite solution, eliminating material waste and carbon emissions. Our innovative approach utilizes a modular and agile microwave depolymerization system that seamlessly integrates into our client's current setup. The system consists of 3 segments that work in synergy to achieve full circularity. First, our multi-phase microwave reactor selectively depolymerizes the matrix of the composite. Then, 2 plasmas are employed, a non-thermal and thermal plasma for secondary cracking and conversion to nanomaterials. The result is chemically recycled composites. And with our multi-phase reactor and fractional condensers, we are able to capture numerous products according to their boiling points, such as monomers, oligomers, and others to a very high purity. This results in clean fibers with or without their original sizing. And the remaining carbon residue is transformed to nanomaterials, such as graphite, graphene, and nanotubes. One of our unique selling propositions is that our process is feedstock agnostic, eliminating the need for any pre-processing. Additionally, our process is containerized and mobile, resulting in a flexible and singular solution. We are extremely excited about our current traction. We have won numerous startup accelerators and have delivered over 50 proof of concepts for various industries. We can offer capacity services, joint venture with partners, and licenses for customers to use our technology. We take intellectual property very seriously, having filed 10 patents with status pending or granted to protect our valuable innovations. Based on our current projects, we anticipate a base case revenue of 54 million Swiss francs by 2027. Furthermore, taking into account pre-orders, we foresee a potential upside case of 108 million Swiss francs in 4 years. Our EBITDA, also in 4 years, lies between 21 million and 45 million Swiss francs. Partnering with Microwave Solutions means joining a team of experts who are committed to revolutionize circularity in the composite industry. With our cutting-edge technology and our forward-thinking approach, we understand high-power microwave systems, systems integration, chemical engineering, and have business-to-business expertise. Together, we can make a real impact in achieving full circularity in the composite industry. Let's join forces and pave the way forward to a more sustainable and profitable future with Microwave Solutions. Thank you so much. Thank you.
There we are, ladies and gentlemen, Microwave Solutions. Fantastic. No, you turn around. It's okay. It's all right. Just come back here. I know the nerves get to us all. Come. This is, you don't go off. This is actually the best part. A bit forward here. This is the best part. This is where the jury they ask you questions more about what you're talking about. Let's hear from Karl-Heinz.
Thank you very much for your interesting presentation. I have a question concerning the output of your separation or recycling method. Can you tell us something about the purity you can achieve?
So what we can do, we initially always do fractional condensation together with our multi-phase reactor, and we try and achieve a purity that's good enough for our customers. If that purity is not good enough, we can do distillation, and with distillation we can achieve very high purity, up to 99%.
Okay, thank you.
Do you have competitors, and how do you differentiate from them?
So there's a lot of companies that do pyrolysis, but that's almost only thermal heating. What we do is selective depolymerization, which uses microwave energy to depolymerize the matrix of the composite. So that's how we differentiate ourselves from the competition.
Time for one last question. Yeah, quick one.
So how would you describe your business model? Is it licensing and selling technology, or you're actually going to run the processes?
Yes, so like I said, we can offer capacity services. We can offer joint ventures with partners, so we can work together. But in the end, we want to sell licenses to customers to use our technology, and we will integrate it into their current setup.
Cool, thanks.
And there we have it, ladies and gentlemen, hands together for Microwave Solutions. Thank you so much. There we are. We all very diverse, very different, each have their own qualities naturally, and all made it naturally as a finalist within this startup competition, so they deserve to be here. But the question is, who will walk away a winner? Maybe we already have a winner from the startups that have pitched already. I'm sure if I ask you, who do you fancy walking away a winner? Maybe, probably, if I could see through into your brains, maybe there would be very different indeed. We'll find out tomorrow at 3 o'clock. Right, let's move on. So we walk away from, well, Switzerland moves away from Paris, but joining us here in Paris is a startup from France. So they haven't got far to go at all, naturally. So this is all about a disruptive approach based on long fiber realignment that maintains the high performance of carbon fiber. Let's hear what all this is about right now. Please welcome to the stage CEO and co-founder of Nova Carbon, Hugo CARTRON.
Thank you very much. Thank you very much. So I'm Hugo CARTRON, co-founder and CEO of Nova Carbon. I'm a composite engineer, previously working at Dassault Aviation and Safran. My co-founder, Vincent Gamboa, has a strong experience in the circular economy around carbon fiber. So he has founded Sports Carbon, a carbon fiber bike repair company. And he is also a volunteer in Recycling Carbon Association. So carbon fiber is a wonderful material, but it's really unsustainable. So more than 90% of carbon fiber waste is either burnt or landfilled. Other people said it a lot, and I said it again. The amount of carbon waste is going to be increase. So it's going to be exponential. It will double in 2030, and it will be multiplied by 5 in 2040. So what we want at Nova Carbon is to make the carbon fiber recycling viable. Actually, we've known how to separate the fiber from the resin for 20 years. But the thing is, the classic process to make semi-products are based on cutting and shredding. And we want to, and this leads to low-performance semi-product. We want to make high-performance semi-product with an optimized process. So this process has been developed at the University of Bordeaux in France through a European project called Magnifica Recycling. Our innovative process accepts a wide range of carbon fiber waste, so from dry fabrics to dry fibers or depolymerized fibers. We are not doing that part. What we are doing is we are making unweaving and realigning the long fibers to make high-performance semi-products. So what we do is preserving the length to keep the high performance. So our semi-products are high performance and also sustainable. As you can see on the graph, you have two mechanical properties, specific modulus and specific resistance. We are just in between the UD, the virgin carbon fiber, and the glass fiber in yellow, and metal in red. We are also more competitive than carded fibers and chopped carbon fibers, recycled carbon fibers. We are also very sustainable because we, compared with virgin carbon fiber, we are between 10 to 100 less, generating less than 10 to 100 less CO2 than 1 kilo of virgin carbon fiber. Depends on from which waste we are actually recycling the carbon fiber. So our priority markets are sports, nautism, light mobility, good transport, construction, automotive. We are expected EU market to be at 2 billion in 2030, and we have already a confirmed traction through prototypes we've made with potential clients and letters of intention. As you can see here, you have cycling and running shoes made by Decathlon with our materials. And here, the first pultruded plates in the recycled carbon fiber, made with Epsilon Composites in France. Our team is from the University of Bordeaux in France, where the technology has been developed. And we have the chance to have the inventor of the technology in our advisory board, but also experienced people from renowned carbon fiber companies. So now we want to finalize the development of the technology. We want to certify the first semi-product and launch the production at scale. That's why we are fundraising before 2024. And we are continuously looking for new technical opportunities, which means testing new carbon fiber waste, but also providing samples of our semi-products based on recycled carbon fiber. Thank you very much.
Nova Carbon. Well done. Right on time. Right on the gong. Where are you going? Come here. Nobody wants the questions anymore. Right. This is where we find out more about what they think about what you've just said. Let's go.
So thank you very much for your presentation. Super interesting.
Could you elaborate a little bit more about your business model and the way you are planning to scale your business?
So business counts, you said?
Business model.
Model, okay.
So how are you making money out of this?
Actually, we are selling semi-products made with recycled carbon fiber. For the moment, our semi-product is a dry UD tape of 15 millimeter wide and as long as you want. But we want to have a wide range of semi-products based on these long fibers, recycled carbon fibers.
And the second portion, so how are you going to scale the business?
Actually, to scale the business, it's just to make the machine bigger, make it more homogeneous, the semi-product more homogeneous, and to be sure that we will get this recycled carbon fiber from suppliers that are doing the thermolysis process or servolysis process like previous partners.
Time for one more question. One more, yeah, quickly.
Maybe, yes, quickly. Question on the cost. What is the improvement of cost or the up cost of?
As you saw, it's a material that is in between glass fiber and carbon fiber. So the cost will be as well in between glass fiber and carbon fiber. We don't want that to be more expensive than the cheapest carbon fiber on the market.
Okay. Right, ladies and gentlemen, hands together for Nova Carbon. Thank you so much.
Thank you very much.
Wonderful, great. There we are. There we've already heard lots of great ideas, and we're going to hear a few more coming towards the end, the last part of this category right now. So, UK, a UK-based startup. This is all about composite tooling, automating the design and manufacture of composite tooling. Let's find out what this is all about. Ladies and gentlemen, hands together for the CEO of Plyable, Martin Orton. Who gets the gong? There we are. This usually happens at the end. It means you leave. It means you leave. No, stay.
Yeah, hi, my name's Martin Orton. I'm co-founder and CEO. I'm excited to share with you Plyable, online manufacturing platform specifically for composites. So, composites are needed today more than ever before. Efficiency is key in how we move people and goods around. The problem is that manufacturing with composites is hard. I'm sure everybody in the room is as passionate about composites as we are, and at Plyable we're all in on composites. My background is a composites engineer. Before starting Plyable, I was designed and built composite structures for 7 years. I was head of design for an America's Cup team. And during that time, I noticed that tooling was one of the big barriers to composite production. It can account for up to 50% of the cost of bringing a product to market. The supply chain is super highly fragmented, and this often leads to suboptimal products making their way to production. So when we set out to build Plyable, we had the big, bold vision of how can we create the largest composite manufacturer ever to have existed, but to do so without owning any machines. Our approach is that we can use the capacity and capability that's out there in the market and enhance the collaboration to enable more efficient production. So, to date, we've started that based on tooling. I've said it before, it's the first part that's needed when you're making a part. Every part first needs a mold or tool. Our unique patented software enables instant quotes direct from component CAD. What we've done is taken a multi-week process and condensed it down into minutes. Plyable is the only online tooling supplier in the world. We also have the largest composite tooling network. It started in the UK, but as our customer base has grown, so has our network of manufacturing partners. We have a team of in-house composite engineers that work with our customers, but Plyable is a technology company. We have a team of software engineers that develop our own highly differentiated software that automates previously manual processes. For instance, we see that tooling is a mathematical function of the part you're trying to produce. after the part is uploaded, we use computer vision and AI to automatically determine mold solutions. From this, we then know how many pieces the tool needs to be, the size and geometry of those, as well as the desired tooling material. From there, we can run it through our automated pricing algorithm and give instant, accurate quotes for mold tools. Once the quote becomes an order, we are then able to automatically issue work instructions to our network of manufacturing partners and have been able to deliver parts in 24 hours. It's faster than even our competitors can quote. On top of all of this, Plyable is built upon bank-level grade security. Parts are anonymized at the point of upload, and our technology is even ITAR compliant. So what? The so what of all of this is that we save you time and money. You know, since sitting in the back of this hall over 4 years ago with just an idea, we've grown from £0 to over £5 million in revenue last year. We've got thousands of monthly users and an impressive customer list. For instance, Vertical Aerospace, we went from them uploading CAD to them flying in Wales in less than 90 days. No other supplier could have achieved this. With GK and Aerospace, we did our most detailed study yet. Well, we benchmarked ourselves against existing data set of tools, and we're shown to be 44% faster and 20% cheaper than their incumbent suppliers. You know, this department spent £30 million a year on tooling, so we're talking about significant savings. Last year, not for GK and Aerospace, and I can't say who just yet, we delivered over 3,000 unique mold tools. At its peak production, we were delivering 300 molds per week. This was only possible due to the unique automation technology and our distributed manufacturing model. You know, as a result, there's no more crystal clear case study of the benefits of Plyable. As a result of our automation technology, a new product has been able to come to market that would previously be unviable due to costs and lead times associated. As a small team, having a single laser-like focus has enabled us to gain early product market fit and good traction. But we're not started yet. We're not finished yet. We're now able to offer further services, more than just molds, but also part production, further leveraging our technology and our network effect. And I think, you know, this is probably the most important thing. We're here for 3 days. Come and say hi. We're here to have conversations, so please do come and see us. We're either going to be at the Startup Village or on Hall 6 stand H4. Failing that, go online to pliable.com, give it a try. It's free.
Ladies and gentlemen, hands together for Plyable. Fantastic. Come and join me. Fantastic. And again, absolutely right what you said there. Everybody here is what? Here for conversation. So all our startups here on stage, whether it's this morning or right now, if you're curious, you'd like to know more, reach out, or even better, go over to them, have a chat with them, have a coffee, and get to know a little bit more about what's underneath the bonnet and what makes them tick. And that's exactly what we're going to do right now from our jury members. Let's hear what they say.
Thank you very much. Thank you very much. Really good presentation. I had a question on the connection to an ERP, because if you make a lot of production, the company will need to connect to their ERP. So how do you address this point?
So, I mean, that's probably getting into part production rather than tooling production. Am I correct? So, you know, we started with tools because they're a really great way to generate these network effects. Like at the moment with parts, we're limiting to low run volumes, so up to maximum 100 parts. To date, we're doing it with a few key accounts, and the most we've done is 30 parts. So we understand that ERP integration is coming. We don't know what that looks like yet, although we've got some ideas. So I'm sorry I can't answer that more clearly, but it's on our roadmap.
Very good presentation, thank you. Question for me is around quality. How do you control quality through the process?
So we clearly rely on our supply chain to do that. You know, quality is key. And again, starting with molds was really critical there. It's a lower barrier to entry, and quality there is more about, is it the right shape rather than, are we going to be building a flying part? 80% of our revenue is commercial aerospace. And so we were able to get close to our enterprise accounts, understand what quality looks like to them, understand what's important to them from a tooling production point of view before moving into part production. We rely entirely on our supply chain to manage quality, but we do that through our digital thread. So, right slide's not behind me anymore, but online, once you're going through the upload process, everything is in a digital thread. So from the point of upload to the quote, all the technical information is kept there. Once it's in production, you can see it. In production, you can see quality inspection reports, NDT reports getting uploaded, all in one place, not in emails, not in sidebar email threads, and you can share it with the right stakeholders at the right point in time.
Cool, thanks.
And there we have it, ladies and gentlemen, hands together for Plyable. Thank you so much, wonderful. There we are. They just seem to get better as we're going along, don't they? Lots of diversity, very different indeed. Difficult to choose a winner. So in front of me now, 5 expert judges here. It's going to be a tough call, I'm sure, a little bit later on when they come together and try to decide who actually is the winner, who walks away winner of this category. Could you do it? I'm not sure. I certainly couldn't. We'll find out tomorrow, though. Remember, 3 o'clock on this stage, the winners will be revealed. And remember, what do they get? 25,000 euros package prize. 25,000 to the value of 25,000 euros. So a startup booth here, 2024, here at JEC World 2024 in Paris. Also, media coverage, lots and lots of valuable media coverage as well, and a cash prize also. Let's move on now to our next startup. So this is intelligent process monitoring for composites. Let's find out what that's all about. Please welcome to the stage right now, Managing Director of Synthesites, Nikos Pantelelis.
Good afternoon. So my presentation today will be about a product that we have been developing in quite a few years now, about improving the composite manufacturing quality, performance, and I will focus more about the curing, which is now our main product. So you know very well that in all the thermoset composites and the thermosets, they are being cured. And curing, most of the times, captures the majority of the process cycle. For the moment, currently, what is being done is everyone has a fixed cure profile, which is being followed quite accurately during production. And this is something that is being, perhaps it's being monitored, but you can only check the quality of the part after demolding. And this is very important. So for the moment, it seems that the most, let's say, advanced composite parts are being produced with some very conventional and I would say old-fashioned technology based on recipes. Of course, in order to deal with fluctuations from batch to batch variation of resin and other things, you always have a safety factor on this, let's say, optimal cure profile. So you always end up with some more curing time in order to be sure that at the end you are going to have the quality that you need. So it's very, for example, this is a standard cure cycle for RTM6, and it's quite common that you add 1 hour in order to be sure that at the end you will have a very good quality. Our product is about having an online measurement of the curing, And this can help, of course, to ensure that you have the right TG at the right time, and then you can start, let's say, the demolding procedure, the cooling or the demolding procedure. And as you can see here, it's both for any thermoset, so from liquid resin to pre-preg or adhesive. So we can, someone can use this in several, for several resins and several products. This is a typical cycle that you can see, you can meet in wind energy. And we managed to save 70 minutes in this case. And this is, moreover, this is something that we have, let's say, validated with our customers. Just to have an idea, we have already been working with several customers in wind energy, in automotive applications, and also we have been working a lot in aerospace. Always with the same target and the same and similar benefits. Of course, you can use our equipment and software both in the development but also in the production stage. Just to have a better idea to illustrate what you can see with our software. First, in this case, we have an RTM application first. So first you can see the flow front and how the flow front moves. At the same time, you can have an idea of the viscosity, especially if you have a fast curing resin. And then when the filling concludes, we go to the curing cycle, and you can see it's changing. We have developed this software, so an HMI that the operator can use also in production without any idea of what is it behind. You can see the temperature and resistance, electrical resistance that is being measured. And from this, we can calculate online in real time the TG. And when the target is being reached, we have an alarm to inform the customer about the processes end.
And we know what that means. It means we're out of time, unfortunately, only because we have to keep it fair and square with absolutely everybody. Ladies and gentlemen, hands together for Synthesites. There we are. Come and join me. Come and join me. Okay. Maybe some of the things that you didn't say, maybe we can share it now through this, if it comes up in a question.
Oh, there are many things that I haven't said.
Yeah, but you can't say that until they have to ask you a question. They ask you a question, and then if you can put it in the answer,
okay,
it might work.
Okay.
Let's see.
Sounds good.
Thank you very much for the presentation. I love the illustrations as well.
Thank you.
Brilliant. For me, the real question is, how do you describe your revenue generation model? How are you going to create money in this business?
We are already generating money. So for the moment, we are self-sustained. But of course, we hope to earn much more. And the idea is to sell license with the software. And actually, what I didn't mention is that we have also equipment which are being sold right now by our mother company, which is based in Greece. So we have the sensors, and all the equipment are being manufactured there. And we only provide the software. So the license costs some money, and this, for production, it's an annual license. So we hope that we can generate, because our target is production, it's not the laboratory. So we hope that we can generate some revenues, revenues from the license.
Cool, thanks.
Could you mention a few words about the team that you're working with?
The team, we are not many, we are few, but we developed this software. With the software, you don't need a lot of people to work. But also, what is important in this software is the process, because this is customized for a specific resin. So we need to work with our mother company in Greece to develop these, let's say, models in order to have them It's myself. I have been working in composites for more than 20 years in composite manufacturing. And as you can see, we are working with a whole range of composite manufacturing, from wind energy to aerospace. For the moment, I think we are coping well with all these different applications, because the requirements from and the specifications from wind energy to aerospace is quite different.
So it's not one standard software, it's a specific development for each.
The platform is standard, but then we need to customize this for specific resin and specific application. And we also adapt it to the specific requirements of each customer.
Ladies and gentlemen.
But this is not so time consuming.
Ladies and gentlemen, I'm so sorry I have to stop. I'm sure if you could carry on and go longer than the pitching, but yeah, absolutely. Ladies and gentlemen, hands together for Synthesites. Well done.
Thank you.
5 minutes, 5-minute pitch. For many, 5 minutes can be a lifetime. For others, very quickly indeed. And think to yourself, could you stand here in front of an audience, an audience as beautiful as some of you here in the audience right now, strangers doing it in front of so many people as well. Quite a tough task to do, but I think you'll agree with me, lots of diversity, lots of intriguing ideas, and hopefully it's given you lots of curiosity as well. Enough to maybe visit them over at the Startup Booster Village, have a chat, have a coffee, and get to know some of the startups that you've got a little bit of curiosity about, and see where those conversations unfold. Let's move on. We move on now to, I keep saying we move on. In fact, they come to us, as I say. They come to us here in Paris. It's the Netherlands coming to Paris right now, and this is a next generation advanced material company that is turning waste into new circular materials. Let's find out more right now. Please welcome to the stage CEO of TerraWaste, Aija Pope.
Eight years until irreversible climate disaster will occur for you, for me, for your children, and for everybody. My name is Aija Pope, and I'm the CEO and co-founder of TerraWaste. The problem that we are facing today is that petrochemical and plastics companies can't provide market with sustainable or recycled materials at needed levels with existing technologies. Even more so, only 25% of the recycled plastics demand can be met by 2030. Only in Europe alone, more than 680,000 tons of composite waste will be generated in 2025. Of course, there are other technologies that are contributing to solving this problem, but they still pollute the environment, they use enormous amounts of energy, and they can deal with limited waste streams. That's why TerraWaste has created a solution, HTL Loop, which is a advanced thermochemical conversion technology that is converting and upcycling plastics into new circular materials, or basically we mimic the accelerated version of geological formation of fossil fuels. So what Mother Nature can do in 10 million years, we can do in 45 minutes alone. So how does it work? We use mixed plastic waste, we shred it, then we add water and catalysts, mix everything together and transfer it to the reactor, where we apply heat and pressure, and then we boil the mass for approximately 45 minutes, and as an output material, we generate crude oil, high-value chemicals, and biochar. The thing that we are most proud of about our technology is the engineering solution, which allows us to reuse heat and water in a loop, that way dramatically decreasing the energy consumption. The main product that we produce is synthetic oil. We call it internal oil, which has properties close to the virgin oil extracted from the earth that is good enough to produce food-grade plastics, packaging, automotive plastics, textiles, medical plastics, and many, many more products. The technology itself is 100% stable, sustainable, produces 85% of yield from the materials, and it uses 50% less energy than any other competing technology. The team behind TerraWaste has more than 20 years of experience in oil and gas system engineering and pilot and plant procurement, and more than 40 years of business development and entrepreneurship experience. Our advisory board is very well connected globally and is actively taking part in our success. In the last 12 months, we have signed 6 letters of intent, have signed pilot commitment in Austria, went through Techstars acceleration program, produced our first oil, and formed new partnerships with Ernst & Young, Amazon, and GreenTech Campus in Austria. In the next 2 years, we will build our first pilot plant located in Austria with a capacity of 100 liters per hour, and we plan to reach industrial scale by 2028. Our company is technology as a service type of a company, and our main income streams are from lab tests, EPC contracts, licensing, and oil sales. Our total addressable market is enormous, more than $1 trillion, but we will start with a minimum, approximately $77 billion, which is recycled plastics only. Our current focus is on CPG, automotive, aerospace, and marine industries. By using TerraWaste technology, composites industry will benefit by low carbon materials, enhanced material performance, reducing production and sourcing costs, new waste-to-value solutions, regulatory compliance, and future-proofing the industry. Our vision is to enable the world's transition to sustainable materials and recycle waste at gigaton scale. We are looking for industrial partners and seed round in the amount of 4 million euros for customer acquisition, building our first plant, team expansion, and acceleration. My name is Aija. Please join us on the journey of making our world more sustainable and circular. Thank you very much.
Ladies and gentlemen, hands together for TerraWaste. Fantastic. Okay, come forward. Right, let's hear more from our jury members and hear how they felt about TerraWaste.
So, thank you, Aija, for your interesting and enthusiastic presentation. I have a question. There's a big competition in this area, what I know, and the question is your technology more technology which will take place in some locations, meaning doing a high invest with only a few pilot lines, or is it more a technology which will be distributed in a small, medium size in many places, because the waste business is in every country very specific, in every location it's specific, it's mixed waste, it's also like food also included, and the plastic management of the waste is transforming at the moment.
Thank you for the question. So we are currently planning on building various, I would say, mid-sized, not small-sized plants, and operate all over the globe, basically. But mainly the size of the plant would be depending on the customer needs, as we are not only servicing the waste management companies and recycling companies, but also corporate companies that are producing waste in their own production lines. So basically, we would be closing the waste loop not only for the waste companies, but also for the companies that are producing their waste on in their production lines. So it very much depends. We're approaching this case by case at the moment, and once we have enough case studies around different waste streams and waste types, then we can start to modify it and enlarge the scale of the plant and deliver waste to the one specific plant and to recycle it at a very large scale that would cover the costs of logistics, etc.
Okay, thank you.
Another question from our jury members, perhaps. Hello.
Indeed, thank you. Very interesting presentation. What's your route to an affordable solution?
Right, so we are starting with performing tests for different types of waste streams. So we currently have plastics, forestry industry, food waste, and agricultural waste. And after that, we have already, it's some sort of a feasibility study for the specific waste stream. Then we are coming with a proposal to the specific party with the offer of building the plant specified for their waste stream, and we are taking it, as I mentioned before, case by case, client by client, and yeah, we have already one signed client, and we are looking at 3 more in the pipeline in the same specific way. So first it's test, then it's a commercial deal, and then we are building the plant for their specific waste stream.
Thank you.
And there we have it, ladies and gentlemen, hands together for TerraWaste.
Thank you very much.
Well done. There we go. Believe it or not, we are now on startup number 10. We have listened to, or more importantly, focused, dedicated listening, sitting here, giving up their time, their energy. I can see, I know it's tough, but you're doing a great job. And that will all tomorrow, once we find out who the winners are, I'm sure certainly the winners will be grateful for your help, your energy, and your knowledge as well. So you don't have to sit here and do all this. All you have to do is sit back, relax, and enjoy these great big ideas here on the stage. Let's move on now to our last startup, our last big idea of this session and of the Startup Booster competition as well. From Taiwan, or as I say, Taiwan comes to us here in Paris. This is a microwave pyrolysis technology solution. Please welcome to the stage consultant from Thermolysis, Calvin Wu.
All right, so good evening to everybody. It's been a pleasure to be here. And yes, I'm still having jet lag. Okay, it's quite far away from Taiwan. All right, so today I would like to share our big ideas with you about our carbon fiber from recycle to renew. Okay, so from the past history that we all know that whenever there's something new, we will have consequences. And usually it ends up pretty bad, okay? We are fascinated about carbon fibers with its cool-looking, beneficial features, and probably a replacement for metals. Okay, but if we are not careful with these carbon emissions, or even with the recycle measurements, we probably will be soon in troubles. So our solution here is to deal the carbon emission and recycling at the same time. Here is our up-running patent production recycling pipeline that's already built in Taiwan. We have 2, one in Taichung and one in Kaohsiung, okay? And it's already in production, as well as we have roughly around 200 tons per year for RCF. So we retrieve these leftovers, prepreg or CFRP waste from PIR or PCR, and we make it into our own product, recycled carbon fiber. So as you can see from the pictures, that we actually quite clean and undamaged surface compared to the competitions. Okay. So we've obtained the UL2809 recently, and it shows that to prove our recycled carbons is 100% recycled carbon content. As well as we have acquired ISO 14067, which that shows that for every kilogram of recycled carbon fiber that we produce, roughly around 5.047 carbon CO2, okay? And we are targeting to get down lower to roughly 3 kilo by emissions, which is fascinating is that if we compare to virgin materials, for every kilo that they produce, roughly is around 20 kilos of CO2. So we are like 75% less if we are looking for the longer pictures. Okay. So what we do with our recycled carbon fiber, we try to present incentive to the market. We try to make this a collective, cause, not just by us, collective cause, actions. So we make it with RCF paper, mat, or master batch, And we actually been tested working with several companies or in industries, such as in electronics with PC laptop, PC boards, and in sports like a rocket, or bicycle frames, or even in aerospace like for drones. So here's our teams. Our team is leading by several PhDs with staff roughly across Taiwan, about 30 people. And we work heavily with the local institutions, academic partners, try to improve our R&D day after day and also get a clear verifications. So what we hope is, first of all, our patent portfolios across the world to make a better insurance for ourselves and our investor at the same time.
The show is not closed. We hope you enjoy.
So for our next stops, first of all, we would like to invite the brands to join us into our recycle and reuse program.
You can. Okay, carry on.
Thank you. Okay, so I would invite the brands to join us into this recycle and reuse program. Make this really a collective actions, not just by us or parts of people, but into these collective actions. And we also provide them with the RCF products, so they can have this to make into their own interesting items. But we all know that we have sayings like the RCF is always incomparable to the virgin, which, yeah, we know that. But what we can do is make it better and better. So we are actually trying to our formulas by adding some other secret cells into our RCF and try to make it in the mechanical and thermoplastics, make it better.
A couple of more seconds, go for it.
Thank you so much. So, lastly, we would love to have your sponsorship and to invest in our R&D in the future. But most importantly, we are trying to fulfill our dreams to have non-man factories in the world. Thank you so much.
Ladies and gentlemen, hands together for Thermolysis. Well done. That's microphones for you. Come and join me in the center here. Fantastic. Right. Okay. Let's feel and hear how our jury feel about what they've just heard.
Thank you very much, Calvin. Very interesting and great to see that you have a pilot production already. What's your commercial strategy to grow that?
First of all, we are working quite a lot, closely work with the brand. Okay, so we try to get their waste from them, and we symbolize this. We deal with it, and we provide their wishful items like in mat or in master batch back to them. Like that's how we're working at the moment. Yeah.
Thank you.
Thank you.
Another question perhaps from our jury members. Or are you happy? You're happy with what you've heard? All good? Fantastic.
No, that's good.
Wonderful. Ladies and gentlemen, hands together for Thermolysis. Thank you so much. Well done. There we have it. Believe it or not, we have just been through 10 different big ideas here on the stage, each very different, diverse, and I'm sure it has sparked some curiosity and triggered your curiosity as well, hopefully to start a conversation and take that forward as well. What will happen now very shortly, our jury members, while you make your way home and leave and do what you have to do after a long day here at JEC World Day number 1, our jury members, it's not very different for them. They will come together, they will meet in a very dark place, in a cave somewhere in the depths of Paris, and they will decide secretly who will walk away winners of our category this morning, this category right now, and our most sustainable solution as well. Ladies and gentlemen, that is the end of the JEC World Startup Booster competition. Remember tomorrow to find out who walks away winners of 25 5,000 euros valued package for JEC World. Find out right here, 3 o'clock as well tomorrow afternoon. All that leaves me now to say is thank you so much to our sponsors and our partners, but more importantly to Karl-Heinz, to Krista, to Turlo, to Raphael and to Christopher for giving up their energy, their knowledge, but most importantly, their time as well. Ladies and gentlemen, that is the end of the competition. See you tomorrow at 3 o'clock to find out who the winners are of this competition. Good evening.